Okay, moving on to graphing tangent and cotangent. Clearly from the picture, tangent is very different from sine and cosine. Remember, as you go around the unit circle, we are starting at 0, and the slope of that line is 0. But as you go, pencil, you can see the slope slowly starts to increase until it's so steep that the slope is actually undefined. That's pi over 2, which is down here in my table. We'll talk about why in a minute. And then when you get back around to negative pi over 2, that also has an undefined slope. So for tangent, our green line, right, our midline, is still right here. One of the big changes is that the period is only pi for the parent graph. So that means period is going to be pi over b for all the other graphs that we do. The middle of tangent is on the green line. So the phase is going to be the middle, which is a huge change from sine and cosine. And then you can see that the asymptotes, that's what the computer's little gray lines are. Those are the asymptotes. Well, the middle of that means that the beginning is going to be an asymptote. And it's going to be middle minus the period over 2, right? Half the period to the left will give me an asymptote. And then the end is also going to be an asymptote. It's going to be middle plus the period over 2. Might make more sense when we do one with numbers. But this is some stuff I need you to have written down before we move on to graphing tangent. Again, it repeats, right? We're going to graph one tangent curve, but it does go on and on and on forever. Okay, so then once we have our tangent, which is represented in black here, we'll do it in light gray or light pencil. And we've got our asymptotes that the computer didn't draw, but there would be an asymptote. Can you even see yellow? I'm going to make it gray. There'd be an asymptote here to go with that black tangent curve, and an asymptote here to go with that black tangent curve. And I'm going to do one over here as well. So we've got 2 tangent curves. We still have our midline, that green line, which is important. So wherever tangent touches the green line, so right here is where tangent touches the green line, and right here, that's a 0 for tangent, which means it's going to be undefined for cotangent. So you rip it at the zeros again. The red is the beginning of my cotangent curve. Then, opposite is also true. Wherever the asymptote of tangent, the gray dotted line, touches my green line, that becomes a point of cotangent, right? The reciprocal of undefined is 0. And then this point of tangent is a point of cotangent, and this point of tangent is a point of cotangent. And this new red curve that I'm trying to make extra dark for you guys to see is your cotangent curve. Same thing, period is pi over b. That's different, right? We're not used to pi over b, so don't forget that. Tangent and cotangent have no amplitude. They have a vertical transformation instead. Okay, let's jump in. This one's tangent. So, tangent does not have amplitude. It has vertical transformation. It might have a vertical reflection. Period. Phase. Vertical shift. It's not going to be an answer blank, but I do need to know the middle and the beginning and end. So this is going to be a little different now, right? I need the middle first, and then we'll find begin and end. Okay, so vertical transformation. There is a 2 in front. So you look at A to determine transformation and reflection. 2 means it's stretched. Positive 2 means it has no vertical reflection. There is an imaginary 1 in front of that x. So period for tangent is pi over that imaginary 1, which is just pi. Phase shift minus pi is going to move it right pi. Vertical shift plus 1 is going to move it up 1. The middle is the phase. The middle is going to be pi. So that means I'm going to split the period, half of it to the left of pi and half of it to the right of pi. So the beginning is going to be, now we've got a lot of pi's going on. This pi is yellow for period. This pi is orange for the middle. So you're going to take your middle, you're going to subtract the period over 2 because you're going to move half of the period to the left. Common denominator if you need it, that's that's positive pi over 2. 1 pi minus half a pi. The end is going to be pi and half of it to the right. So the middle, and then half the period is to the right of the middle. That's not the right color. Which is going to give me 3 pi over 2. Okay, it's all on the positive side. Let's use black. And it's up 1, so maybe down here. Okay, my values in the margins are all counting by 2's. So pi over 2, 3 pi over 2, 4 pi over 2. I end at 3 pi over 2 anyways, so that's plenty. My y-axis is counting by 1's. Green line. The vertical shift is up 1. The middle is on the green line. What happened to 2 pi over 2, you guys? No one told me I forgot 2 pi over 2. It goes pi over 2, 2 pi over 2, 3 pi over 2, and then 4 pi over 2. Okay, so my middle is at pi, which is 2 pi over 2. The middle of tangent is on the green line. Half the period to the left lands me at pi over 2. That's an asymptote. Remember, the beginning is an asymptote, and the end is an asymptote for tangent. The end, 3 pi over 2, is an asymptote. Then, this tangent has got has a stretch, a vertical stretch of 2. So it is going up to the right. Think of it kind of like cubics. It's not a cubic, but I understand how that's an easy way to think about it. So halfway between the middle and the end, there'd be a fake tick mark there. Not a fake one, but I had to add one, right? Halfway there, the graph is going to be 2 above the green line. Halfway between beginning and middle, the graph is going to be 2 below the green line. Just like a cubic, it gives you 3 points that could make a straight line, but you need to sketch them in to look like a tangent curve. There's our tangent curve. Okay, there's some answer blanks. I'm not going to write them, but this could be a test day question, so are you listening? Tangents have no amplitude, right? They have vertical transformations instead. So if the question says, what's the amplitude of this tangent graph? You say none or does not exist or whatever the choice is. Tangents also have no relative mins or maxes. So again, does not exist on those answer blanks. Okay, domain. Easier to do asymptote first. The first asymptote, the leftmost asymptote I see, is x equals pi over 2 plus or minus, and it goes all the way to 3 pi over 2. It repeats every pi n. That number comes from the yellow period number. So the domain is going to be all real numbers, comma, x cannot equal that exact equation. The range, tangent hits every value, all real numbers. Tangent cannot be even, right? I can't fold it and have it land on itself, but it could potentially be odd. But remember, if you have a vertical shift, you cannot have an odd answer because this one's up 1. When I flip it upside down, it's going to be down 1, which is not the same. So this is neither. Y-intercept, you might be able to look at it and figure it out. Or don't forget about algebra, right? I'm going to plug 0 into my equation. So y is going to be 2 tangent of negative pi. Or probably write the whole word tangent. Remember, negative pi is here. The tangent value there is 0. So the y-intercept is going to be 0, 1. Which, if you imagine this moving back over here, you probably would have figured out that it would have landed right there. Okay, this is tangent. Now we're going to do cotangent. The good news is we're going to practice tangent again while graphing cotangent. So I'm switching to light gray. You could switch colors or do it lightly with the pencil. And I'm going to graph tangent first. So, bunch of answer blanks for tangent. Okay, there's all my answer blanks. See how many of them you can fill in. You should be pausing this and trying this on your own. So, because the A value is 1, there are no vertical transformations. Because it's positive 1, it is not vertically reflected. Period for tangent is pi over b, which is just 1, so this is pi. Here's my imaginary 1. Phase, opposite the parentheses, right? Plus pi is actually going to move it left pi. Vertical shift, down 1. Okay, the middle is at the phase, but as a number, right? Left pi takes me to negative pi. That's the middle of my tangent curve. So the beginning is going to be negative pi. I need to put half the period to the left, so minus pi over 2. So coincidence, all these pi's again, I'm color coding them to try to help you. Period over 2. The end is going to be negative pi plus pi over 2. Period. Half the period to the left, half the period to the right. Maybe you don't even need to do it mathematically. Maybe you can just do it on your graph. This is negative 3 pi over 2. This is negative pi over 2 if you make a common denominator and do that. See how much of the tangent graph you can get done. It's all on the negative side. So need to leave a lot of room on the negative side. And it's down 1, so leave some space down below. Everything in my margin is counting by pi over 2's. We will end up graphing 2 periods of tangent in order to graph our cotangent graph, but we'll do that when we get there. Your y-axis counts by 1's. Okay, sticking with gray because this is tangent. The midline is down 1. Usually that's green, but I'm sticking with gray because it's not actually part of my answer. The middle of tangent is at negative pi, which is negative 2 pi over 2. Middle of tangent is on the midline. Half the period to the left takes me to negative 3 pi over 2. That's an asymptote. Half the period to the right takes me to takes me to negative pi over 2. And then if I repeat that, it's going to take me to positive pi over 2. And the middle of that is on the gray line. This tangent curve just has an a value of 1. So the halfway mark is 1 higher. The halfway mark is 1 lower. Here's a tangent curve. And the same in my second one. Halfway, 1 higher. Halfway, 1 lower. There's my second tangent curve. Here's why I wanted 2 of them. We're going to rip it at the zeros. So where the tangent curve hits the midline, that becomes an asymptote of cotangent. And if I only have one of those, I only have one asymptote. So where the other tangent hits the midline, that's an asymptote of cotangent. Where the asymptotes hit the midline, that's a point of cotangent, and these other 2 points of regular tangent stay points of cotangent. And here is my cotangent curve. Okay, not even or odd, so it's neither because of the vertical transformation. No relative mins and maxes. No amplitude. Asymptotes first. Remember, this is the red curve. I'm looking at the red curve. One of those asymptotes is through negative 2 pi over 2, which is negative pi, and it repeats every period, pi n. This number came from the period. So then my domain is all real numbers. X cannot equal your asymptotes. That's the whole point of an asymptote. Range is all real numbers. The y-intercept, well, the y-axis is my asymptote, so there are none. Okay, that's it for today. So we will practice this more in class. I hope you guys are doing good.